Section 3.9 is a very high-level application of the tangent line. And this is really going to be a non-calculator application, because if you have a calculator, you certainly would find exact values. If we don't have a calculator, we're going to use this to try to make it manageable. How about that? And the key word here, so linear approximation. You're approximating using a line, linear approximation. Non-calculator stuff, we're playing around with it a little bit. The key word for us is that this is an estimate. It's going to estimate what's going on with the function near a point of tangency. Well, what does that mean? I'll get back to steps and all that in a second. I want to look here and I want to zoom this a little bit. So let's shift gears. Let's just say that in this particular picture, we want to find the equation of the tangent line. Well, what would we do? Well, my x-coordinate is 1, so if I wanted the equation of a tangent line, I would probably start with something like this, y minus some y value, slope times x minus, in this case, my value that I'm using is x equals 1. And so let's go find that y-coordinate to go with it. So let's do an f of 1. I don't want to do this in blue. Let's do this in black. So f of 1 would be 1 cubed plus 3 times 1, which is 4, minus 5 would be negative 1. So now we know what this y-coordinate is that we'd use. And how would we find the slope? Well, slope, we'd take the derivative. So my f prime of x would be 3x squared plus 3. F prime of this 1 that we're using, f prime of 1 would be 3 times 1 plus 3 would be 6. So my slope of my tangent line would be 6. So according to what we have right here, we have this purple graph which is meant to be my f of x. So this purple graph, and I'm sorry it's not the same color, but this is meant to be my f. And this blue graph would be the equation of my tangent line, which after I'm done rearranging it, so let's see, y plus 1 would be 6x minus 6. Y is equal to 6x minus 7. That would be the equation of this blue line. Now, here's what's interesting. I've got it drawn, so at that red dot, which is at the point 1, negative 1, 1, negative 1, the blue graph bumps into the purple graph, right? It bumps into it. That's what it means to be tangent. So let's say you're doing a non-calculator question, and they asked you to do what happens in problem number 2. They asked you, most importantly, to estimate f of 1.01. Well, if you don't have a calculator and you have to punch 1.01 into my f function, you'd have to do something crazy like, let's see, f of 1.01 would be 1.01 cubed plus 3 times 1.01 and then subtract 5 from it. Now, the 3 times 1.01 and the minus 5, that wouldn't be that big a deal, but cubing something like that, that's going to be at least cumbersome. And I guess it's okay if you're using 1.01, but good Lord forbid, they asked you to do the same thing with, say, 0.99 or 0.97 or some crazy value like that. So what we're going to do instead is we're going to take advantage of what we see on the graph right about there. And what you see is that the tangent line and the original function around that red dot, which we call the point of tangency, those y values are almost identical. And I would much rather take on this graph the tangent line's equation, which is y equals 6x minus 7. I would rather take my 1.01 and plug it in here and do 6 times 1.01 minus 7 to come up with what this particular value is. In other words, f of 1.01 is pretty doggone close to what I'll get when I take 6 times 1.01, which would be 6.06. I can actually do that without a calculator and take 7 away from it. This is going to be pretty doggone close to negative 94/100ths. And that's what we're going to do with this tangent line. So what did we just do? I guess if we wanted to think about what happens. Now, maybe the function will tell you, like in this one, at x equals 1, that's the tangent line we want to use. But a lot of times what they're just going to do is they're going to give you this nasty equation, and they're going to tell you, using this linear approximation thing, estimate f of 1.01. Well, so what your steps really are, I guess if we wanted to record them, is you're going to start out by finding the equation of a tangent line at an easy place. For example, x equals 1, x equals 3. A nice whole number that wouldn't be that hard to figure out. And then you're going to plug that value in. You're going to plug in this 1.01 into a linear equation that only has one variable in it and be able to estimate that way. So find your equation of your tangent line at a nice, easy value. So steps, find equation of tangent line at an easy value. Two, plug in your point, or plug in your x value into the tangent line equation. And that's the concept behind this linear approximation. Find the equation of a tangent line, and then instead of having to cube a number like 1.01 or 0.99, heaven forbid, you're going to plug it into a nice equation, nice linear equation, and have some easy numbers to work with. That's linear approximation.